what else is, why do we bother to measure both social and chemical stressors? Why do we spend so much time doing that? Well, we're glad we did, because you don't always only see independent effects of these two exposures, but you see that stress enhances the effects of the chemical toxins, and that if you didn't look at those things together, you really couldn't start to assign the risk groups. Here in this graphic, you can see the upper right-hand box with the circle around it. It was really boys born to women who had both high level of air pollution exposure in this window, as well as high levels of psychological stress measured on that negative event scale. So you start to see you need to look at higher order interactions. Not only that, you have to look across multi-levels, this complexity science. So we measured both air pollution exposure in these communities from traffic. In this case, we're looking at black carbon, a different measure of that air pollution. And then we also measured community violence exposure. So stress at the community level, not just the negative life events the individual is experiencing. And even when you control for those individual level factors, the community violence had a similar impact in magnitude of effect on wheezing, respiratory illness in these kids as the traffic-related pollutant. Traffic-related pollutant we've always been very concerned about, but not so much the community-level stressors. So we learned a number of principles of life course research through these initial cohort studies. Early events may be as or more important than later events, given that we know what we know about biology. There are going to be critical sensitive windows of development that we need to understand, that time factor. We need to understand how risk factors accumulate over time. Social and chemical exposures interact, so we need to be comprehensively measuring things across these different components. Need to consider multi-level exposures, not just the individual, but where you live matters, place matters, etc. And we see host differences, and sex in particular mattered in what we were looking at. So all of this just has brought us scientifically to knowing that we just need to change our perspective to really design studies going forward that can really advance this work even more than we have already. And we can look through a lens that considers both the physical and social environment and across these multiple levels. And the telescope is over time, understanding it over the course of these developmental windows. Now, we spend a lot of time looking at risk factors, and we realize we also have to understand resiliency factors if we're really going to have this translate into interventions and prevention strategies, which we all want this to translate to. And we want to understand that it's the balance between the risk and resiliency factors that contribute to what trajectory you're on relative to your health over your life course. And that's shown and talked about in the reference that's shown on the right side. So how did we start to do that? Well, we had measured a couple of things that we could start to look at as being levers to pull and help with that. We manifested that most through some of the biomarker data that we looked at. So we also want to do, we want to show how does the external environment get biologically embedded. We look across a number of these systems. We're going to talk about it in a reductionist way, but really as the rainbow on the right-hand side of the prism here shows, we really want to get to where can we integrate and understand how these systems that talk back and forth to each other ultimately influence our outcomes that we're interested in. So let's just look at one dosimeter of toxicity that you can look at as a biomarker. Telomere length is often talked about as an indicator. And if you have shorter telomeres, it's typically a measure of more toxic environmental effects over time, and that it has poor health outcomes linked to it. Well, it turns out that starts even in utero, and telomere dynamics in early development are largely determinant of that relative telomere length over life, and that a number of factors starting in utero can have impacts on it, particularly those that affect things like oxidative stress. So we've shown, and we just published recently a paper using that same air pollution measure over time and the data-driven methods to identify who's at risk. We saw that air pollution was associated with shorter telomere length, particularly in boys, But on the left-hand side of this graph, we also took into account the nutrition data that we had in these mothers. And if mothers were able to have high intakes of antioxidants during pregnancy, you could completely wipe out and mitigate the effects of these other toxins. So that's one potential lever. Another is our social scientist colleagues and our psychology colleagues tell us that social relationships can actually be a buffer against toxic effects of psychological stress, but also these other chemical toxins as well. Well, what relationships are important? Well, that may differ depending on the time in the life course you're looking at, but certainly during early development, which we were looking at, infancy and early childhood, human stress response and those key regulatory systems are really under strong social regulation. And it's your caregiving environment that is particularly central and potentially can buffer the effects of these other toxins that you might be exposed to. So it might be a resiliency building factor. And we've indeed showed that even if you have disrupted hypothalamic pituitary adrenal axis cortisol functioning, which is linked to higher increased risk of our wheezing and respiratory outcomes, if we can show that sensitive caregiving is maintained in that environment, it mitigates these effects. So I kind of think about balancing the risk and resiliency factors as this picture of the train switch yard, where someone is trying to make sure things don't get off the tracks or crash. And nutrition and social supports are two levers that we've identified that can actually be those resiliency factors, push people back onto that more optimal developmental trajectory and track and on to better health. Of course, if you go back to the life course strategy, and here we're thinking of lung development, the earlier that you identify the switches and the levers and pull those and intervene, the more impactful that you can be. And again, that is why life course and understanding developmental windows is so important.